What is it that astronomers have found using our new 10 billion toy? It will be years before that project becomes a reality if it goes as planned. The journey to Proxima B will take about 20 years, so realistically it will be several decades before we can confirm if there is indeed life on that planet. The age-old question, are we truly alone in this universe? The James Webb Telescope has discovered some terrifyingly human-esque things far, far away from Earth that lead us closer to the answer. Our search for life outside of us has been rampant throughout each human civilization, so much so that we have thousands and thousands of media, literature, and theories on this subject. Our wonder regarding our place and loneliness in the universe has been constant, as if it is ingrained inside of us to always search for a companion, no matter how alien-like. Well, we just might be getting closer and closer to the answers we truly want. But are they truly the answers we are looking for, or are they much more terrifying? Join us as we explore the latest discovery in the realms of galaxies and planets on the quest to find something we just might not be prepared to witness. Lights far, far away, scientists have discovered what could be the most groundbreaking discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could detect artificial light on another planet, for example, Proxima B. Proxima B, the closest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the dwarf star Proxima Centauri, about 425 light-years away. Since the exoplanet was 20 times nearer to its star than Earth is from the Sun, Proxima B was believed to be tidally locked with a permanent day side and night side, similar to our Moon, which faces Earth with the same side at all times. A hypothetical technological civilization on Proxima B might transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity out of starlight. Subsequently, in a paper with Manas Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since JWST was more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima B. Now, in 2024, it is possible that the James Webb Space Telescope did just that. Using its higher sensitivity and bigger range of capabilities, the JWST might have discovered the lights we were looking for and possibly hurled us into another big surge of human evolution. But first, let us dive into the world of planets and exoplanets to learn how all this was even possible. James Webb's mission explores Proxima Centauri B's secrets. Throughout history, humans have wondered about the nature of the universe. What are we? Where do we come from? And where do we go? These are common yet extremely difficult questions man has tried to answer as soon as he gained consciousness. Now, in the age of exponential technological advancement, one does wonder if we are any closer to any of the above questions. If you would ask a philosopher, he would probably say we are still at level 0 of understanding ourselves and the universe. However, ask an astronomer the same thing, and watch him jump up and down in excitement as he rushes to tell you the latest discovery humans made about the universe using their nifty tools. These tools, although not paid much attention to by the average public, are quite literally a manifestation of human evolution itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips as well. One such way to do that has been deduced by scientists and astronomers. It is through the technology we harness. A specific creation of that said technology is now responsible for the recent discovery of what might light on a different planet, light years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the legacies of human expeditions into space to answer some ever-present questions. Are we alone? Who is out there? Where do we begin? And where do we end? Well, this infrared astronomy tool has already begun answering these questions, although partially. What even is Proxima B? Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri CB. It is a super-Earth exoplanet, and it orbits an M-type star. Super-Earth exoplanets are a class of planets that are more massive than Earth. Yet lighter than ice giants like Neptune and Uranus, they are truly one of a kind. They can be made up of gas, rock, or even a combination of both, and their sizes can vary from twice the size of Earth all the way to 10 times its mass. They really put the super in super-Earth. As for Proxima B, it is a super-Earth and an exoplanet, meaning that it is a planet that traverses outside the solar system. The very first possible evidence of an exoplanet was found in 1917, although it managed to stir up little curiosity and recognition. However, in 1992, the first confirmed detection occurred, which left scientists speechless. Another exoplanet, a different one which was first detected in 1988, was confirmed in 2023. As of the 1st of April 2024, there are 5,653 confirmed exoplanets in 161 planetary systems. Out of them, 896 systems had more than one planet. These marvelous discoveries are orbiting an M-type star right now. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have really low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. The sneaky stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs or M-type MM sequence stars yield a maximum temperature of 390 K, hence getting their name and attributes. Coming back to Proxima B, its mass is known to be equivalent to 107 Earths. Interestingly, it only takes 11 days to complete one orbit of its star, compared to our 365 days. You can estimate the size of the star Proxima B is orbiting. Staggeringly, under the measurement of the entire electromagnetic spectrum, the star has a total luminosity of only about 16% that of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dull even more as it appears fainter. It only illuminates 0.56% of the Sun's luminosity in the visible light spectrum, emitting a significantly less amount of light energy when compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Proxima B. This discovery was announced way back in 2016. You might be wondering, why Proxima B? Millions of stars, planets, and galaxies. So why are we so fixated on this particular celestial body? Well, there are a few reasons that contribute to the keen interest astronomers have in this place. First and foremost, Proxima B is the closest known star to our Sun and by definition, S. Although 42 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Hence, why Proxima B, our closest known star, is high up on the priority list at the moment. It is also a part of the triple star system called Alpha Centauri, and although Proxima B's luminosity is very low, the system itself appears as one of the brightest constellations in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri B is that it might potentially be habitable since it falls under the habitable zone. The possibilities surrounding this star are endless, and thus astronomers have taken on the expedition to explore the depths and limits of the potential of this star. That is where the James Webb Space Telescope comes in. The 4 key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and to study planetary systems and the origins of life. As the JWST continues its exploration of the said exoplanet, we get closer and closer to the completion of these missions, from SETI to exoplanets, searching for alien life. So what exactly is SETI? Considering that humans have always been a curious species, poking and prodding into literally anything and everything that moves and doesn't move, it makes sense that a quest like SETI came into existence on such a large scale. Imagine that God has organized a grand cosmic treasure hunt, but with a twist. Instead of gold, we are tasked to be on the lookout for signals, more specifically electromagnetic whispers from civilizations beyond our wildest dreams. SETI is short for Search for Extraterrestrial Intelligence, and it is our collective effort to detect signs of intelligent life lurking amidst the stars. Our curiosity never ends, does it? Way back in the early 1900s, not long after radio technology came into human use, geniuses like Nikola Tesla and Guglielmo Marconi came up with a new idea. They dared to dream of using these newfangled contraptions to reach out and touch the stars, quite literally. Tesla even went as far as to fancy the notion of chatting it up with Martians using his wireless transmission system. Fast forward to the swinging 60s, and we find ourselves in the midst of Project Osmo, the brainchild of the intrepid astronomer Frank Drake. Armed with a hefty radio telescope and a healthy dose of curiosity, Drake scanned the cosmic airwaves for signs of life. But alas, his efforts came up empty-handed. Yet undeterred, the search pressed on, with scientists around the globe tuning in their antennas to the cosmic symphony. Meanwhile, over in the Soviet Union, our comrades across the Iron Curtain were also keen on the cosmic chatter. Led by the illustrious Iosif Shklovsky, Soviet scientists turned their antennas skyward in search of those elusive signals from the stars. And thus, the stage was set for a cosmic showdown. But wait, what's this? A mysterious signal broke through the cosmic noise, bringing the chatter and nerves up to an all-time high. Dubbed the WOW signal, it sent shockwaves through the scientific community. As the years rolled by, the search for cosmic companions only intensified. From the suitcase SETI to the grandiose Project Cyclops, scientists spared no expense in their quest to unravel the cosmic enigma. And then, in a stroke of luck or perhaps fate, a coded radio signal from Mars graces our Hubble telescopes, igniting the flames of curiosity once more. But what does that exploration really look like now? And how far have humans advanced in terms of space expeditions? Lights on Proxima B. In a 2021 research paper titled Detectability of Artificial Lights from Proxima B, researchers Alice Tabor and Abraham Loeb set out to investigate the potential for detecting artificial lights originating from the dark side of Proxima B. Since Proxima B is a planet located in the habitable zone of its star, the study aimed to assess whether Proxima B might be able to sustain intelligent life and how to detect it. After highlighting Proxima B's significance as a target in the search for extraterrestrial life, they expanded on a juicy yet somewhat scary detail: the recent tentative radio signal detection from Proxima B's direction. It's not recent as it was received yesterday, but when your area of research is literal space where information takes light years to travel, everything is a breakthrough. Generating a significant buzz amongst the science and astronomy enthusiast community, the tentative radio signal added another layer of allure, yet an exciting mystery that astronomers cannot wait to uncover. The signal was detected by the Breakthrough Listen project and represents a potential candidate for an extraterrestrial radio emission originating from the vicinity of Proxima Centauri, the host star of Proxima B. The Breakthrough Listen project, launched in 2015, aimed to survey the sky for signals indicative of technological civilizations beyond Earth. It is in the name of breaking through the barriers of space and listening for any sort of company. By leveraging state-of-the-art radio telescopes and data analysis techniques, the project scanned vast swaths of the electromagnetic spectrum in search of anomalous signals that cannot be readily explained by natural phenomena. This search went on for a long time. In the case of the tentative radio signal from Proxima B, the story is quite precious. Astronomers working on the project detected a narrow band emission at a frequency of approximately 982 MHz. This frequency falls within the range commonly associated with artificial radio transmissions, such as those used for communication purposes on Earth. It was an exciting discovery that opened the door to a whole other realm of possibilities. Even though the observed signal has not been conclusively attributed to an extraterrestrial origin and may have alternative explanations, the discovery is still an immense success in human history. With the signal in place, now came the time to assess the call. The Breakthrough Listen team thoroughly conducted follow-up observations as well as data analysis to scrutinize the signal further. The goal was to assess its likelihood of being of extraterrestrial origin. Although the signal has been scrutinized to the sun and back, definitive conclusions are not possible at this time. The vast empty space we call the universe is not as simple as we would like. 1,000 complications, disturbances, and interferences from terrestrial sources can and will distort the results. As for astronomers, they cannot move forward with distorted results since space expeditions need extreme precision on every part and a lot of money to be executed successfully. Making a mistake based on an inconclusive answer is just not an option. Yet, there is always light at the end of the tunnel, and with the tech we have in our arsenal right now, we just might be closer to finding out the secrets of the universe than we think. The paper emphasizes the importance of artificial light as a potential signature of technological civilizations. Using lights as a marker, the paper theorizes that our expeditions could become really advanced if we use such technology. Proxima B, which is tidally locked with a permanent dark side, requires artificial illumination for technological habitability. The study calculates the light curve by considering various factors. These factors could be the planet's radius, the host star's radius, orbital period, or orbital inclination. All of this is done to estimate how easily we can detect the said artificial lights. It also describes the calculation of light curves using the exoplanet analytic reflected light curve model. It does that by introducing a parameter representing the proportion of artificial light on Proxima B's dark side. By using the James Webb Space Telescope JWST and its NIRCam instrument, the study simulates signal-to-noise calculations. Again, this is done to assess the feasibility of detecting artificial lights. After this, the results were collected and analyzed. According to them, it was indicated that the James Webb Space Telescope could detect lead-type artificial lights comprising 5% of stellar power with approximately 85% confidence. 85% is a huge jump from other inconclusive results. However, the current spectral band needs to be 103 times narrower just to detect the current level of artificial illumination on Earth. The discussion essentially suggests that Proxima B's permanent day and night side could possibly be illuminated by employing the use of strategic mirrors. This clever technique might potentially increase the detectability of artificial lights. The paper then concluded by proposing future extensions of the work. Although the future is uncertain, utilizing future telescopes like LUVOIR could be groundbreaking for improved detection capabilities. James Webb deciphers Proxima B's atmosphere. One must wonder just how we are performing such complex calculations. Thousands of years ago, reaching the moon seemed like a fever dream. Yet now, we are speculating, calculating, and analyzing planets light years away, that too correctly and with accuracy. Well, one of the highest symbols of human advancements is our instruments, especially the most powerful telescope we have, the James Webb Space Telescope JWST. The James Webb Space Telescope is poised to revolutionize our understanding of exoplanetary atmospheres and environments. Yes, that also includes that of Proxima B. These ambitious plans are aimed to be carried out through its advanced observational capabilities. One of the key instruments on board the JWST is the Near-Infrared Spectrograph NIRSPEC. It plays a central role in identifying, categorizing, and ultimately understanding exoplanetary atmospheres. That is possible due to its high sensitivity and spectral resolution. NIRSPEC also enables astronomers to dissect the light from distant exoplanets like separating two strands of hair. This makes it easier to reveal signatures of key atmospheric components such as water vapor, carbon dioxide, methane, and other molecules. And you know how the saying goes, where there is water, there is life, almost all the time. Simulations performed by these astronomers suggest that Proxima Centauri B would have had to wait as long as 169 million years after its formation for it to be safe. This information now makes the habitability of Proxima B extremely dubious. Exoplanet exploration post-James Webb era, space signals, artificial lights, and superplanets aside, the world of space exploration is that of a dark, uncertain, but exciting one. Not only that, with rapid development moving the space research and development industry forward at the speed of light, it might not be too long before normal, average humans are walking easily on the moon. For example, NASA and other private companies already have their sights set on the moon. NASA's ambitious but interesting Artemis program, which has a goal of landing humans on the moon in 2025, aims to begin building a base camp. This dream of having a long-term human presence on the lunar surface is courageous for sure, but it is necessary in a way. These ambitious plans will help NASA prepare for human space exploration beyond the moon and even to Mars. Moreover, as we dream of expanding our reach into the cosmos, we are also learning to appreciate and protect our own planet, Earth, more. The knowledge we gain from exploring other worlds can help us understand and mitigate the effects of climate change and other environmental challenges here on Earth. So, as we continue to explore the universe and search for signs of life beyond our solar system, we must also remember to take care of the precious planet we call home. All in all, the recent discovery and ongoing exploration of Proxima B are just a glimpse of what lies ahead in the world of space exploration. With the James Webb Space Telescope leading the charge in new technologies on the horizon, we are closer than ever to answering humanity's age-old question, are we alone in the universe? The journey may be long and challenging, but the discoveries waiting to be made are worth every step of the way. So let us continue to look to the stars with wonder and curiosity, knowing that the secrets of the universe are waiting to be revealed.